Good morning, boys and girls. Welcome to the first day of NTI for Science. My name is Miss Evelyn. You haven't seen us a while on video, but we're going to go ahead and start. Today is our first unit of Force and Motion. We're going to start with a science experiment and how you guys are going to act as scientists to figure out how they work. And we're going to be working with variables also. Friday, you took your plant animal test, so hopefully your teacher was able to go over that with you. But today, we're going to start our new unit. So you have two posts for today. You have a 1 and a 2. We want you, obviously, if you're watching this, to do this first before you actually do the assignment number 2, which is the actual assignment that you will do. We're going to start with going over variables. So when you have an experiment, you're going to have three variables. They are called the independent variable, the dependent variable, and the controlled variable. So there's three variables when you do an experiment. Now, the independent variable, if you can see right here, is the one thing that you change. You limit this to only one in an experiment. So they give you an example. So this person is growing a type of plant, and you can see there's an A, a B, and a C. Your independent variable, the one thing that you change is the liquid used to water your plant. So in A, they're using a Coke. And then the B, they're using juice, and C looks like they don't have any at all. So the independent variable, the one thing that they changed is the liquid. Now, dependent variable is the change that happens because of the independent variable. So in this one, the one thing that they're measuring is the height of the plant or the health of the plant. So they want to see how much the plant will grow in the time span that they're watering it with Coke and juice and no water at all. So they want to see the height or the health of the plant. That's their dependent variable. That's the change that they want to see happen, what they're measuring, what they're looking for. Now, the controlled variable is everything that you want to remain constant and you don't change it. This is very important. So, if you look at this one, the controlled variables will be the actual plant. They have an A and a B and a C pot. They have the same plants. They're using the same ruler. They're probably measuring it. They have the amount of liquid, the same type of soil, so they're not changing it. That's their control. They're controlling those things. That's what they're keeping constant. Okay? So those are the three types of variables. So when we look at the experiment, you're going to find the variables in those two experiments that we're going to do in just a minute. Now, also, you're going to be learning about how to make a claim when you are a scientist. And we've already talked about what is a scientist. Well, a scientist asks questions and they test those questions. And they do it more than once. You can't just test something one time and, oh, I'm done. I figured it out. You got to do it more than once. So a claim is the answer. The claim is a statement you believe to be true that solves a scientific question or problem. And then you're going to back your claim up with evidence and reasoning. Evidence are the clues that you come up with or that you see while you're doing your experiment. And your reasoning is the why. So, why is this happening? What's going on? It shows how the evidence answers the question or how it solves the problem. Um, we're also going to look at this, and you do this a lot with your E or Q when in ELA when we do race. So you're also going to do it when you make claims in science. So a claim, you're going to start with my claim is blank. What do you get from your experiment? What did you learn? I think or I noticed. Those are your sentence starters for your claim. And for evidence, you're going to use I found, my evidence is, or my proof is what? And then also your reasoning. You can say, I know this is true because, back it up. What's your evidence? What's your reasoning? This happened because, and the reason for this is blank. Sorry, I couldn't see it. So you have a claim, your answer, your evidence, and your reasoning. Okay, so let's get started. So we're going to look at some different experiments. We've already went over your targets for today. You're going to identify variables in an experiment, and we're going to make conclusions and even make some claims. So here's the first one. We're going to do this one together. The second one you guys are going to do on your own. Okay? Samantha wants to grow sunflowers for her mom. She wants to grow tall sunflowers in the shortest amount of time possible. In order to grow sunflowers fast, she decides to perform an experiment to determine the optimal conditions to grow sunflowers. So here's what she does. Samantha learns that fertilizer can help her grow sunflowers quickly, and that's what people use on their grass to make it grow quicker or even their plants. She purchases 3 different brands of fertilizer. She sets up 4 pots, planting 1 sunflower seed in each. She adds 1 teaspoon of brand A fertilizer to pot 1, 1 teaspoon of brand B fertilizer to pot number 2, and 1 teaspoon of brand C fertilizer to pot 3. She plants a sunflower seed in a pot number 4, which doesn't receive fertilizer. She places the pots next to each other on a window ledge. She waters each pot with the same amount of water each day. She measures and records the height of the plants each week for 4 weeks. So let's talk about this. So here is her chart, and this is how she kept up with how much they grow. But first, let's identify the variables in this experiment. So the independent variable, the one thing that she changed within her experiment. Remember, there's only one in an experiment. So what did she change in her experiment? Hopefully you said the different brands of fertilizer. Remember, she put different fertilizers in each one. She did fertilizer A in plant number 1, fertilizer B in plant 2, fertilizer C in plant 3. And the fourth one did not get any fertilizer at all. Okay? The dependent variable in the experiment is the one thing, the change that happens because of it. So she is measuring, and we'll look at it in the chart in a minute, but she wants to measure the growth of sunflowers in the shortest time possible. That's what she's looking for, the change that happens. Now, the controlled variable, remember, is what she keeps the same. She did the same sunflower seed, the same type and size pot, and the same amount of water. And she also put it in the same place to get the same amount of sunlight. So we know what our independent variable, our dependent variable, and our controlled variable is. Now let's go back and look at the chart. So as I can see, pot number 1 with brand A fertilizer, in the 4 weeks that she grew this plant, there's sunflower. In week 1, there was 1 centimeter of growth. Then 4 centimeter, week 2, 8 centimeters, and 3. And week 4, she has 13 centimeters. Grew fast, didn't it? Pot number 2 is brand B fertilizer. Week 1 was 2 centimeters, then 6 centimeters, 12 centimeters, and 18 centimeters. So pot 2 grew a lot more than pot number 1. Now pot number 3, bless his heart, brand C fertilizer. He didn't grow very much at all. In week 1 and 2, he didn't grow. And number 3, he was 1 centimeter. And number 4, he was just 2 centimeters. So do you think that fertilizer works very good? No, I don't think so. And pot number 4 didn't get any at all. Look what it did. Week number 1, it was 1 centimeter. Week 2 is 3 centimeters. Week 3 is 5 centimeters, and week 4 it grew 8. So pot number 4, no fertilizer, grew more than brand C fertilizer. So I wouldn't buy brand C fertilizer at all. It's not very good. So let's look at our questions. Narrative question number 1. What variables did Samantha keep the same for all her experimental groups? And we've already talked about that. What did she keep the same? That would be your controlled variables. She did the same seed, same type and size pot, same amount of water, and the same sunlight, the same position. That's where she kept her plant. So you're going to do this as well in Kami. So I'm going to press my text box and put red, and I'm going to make it a little bit smaller so I can write. I'm going to use, how about 11? So let's see. Samantha, I'm going to say the controlled, the controlled variables in Samantha's experiment are same sunflower seeds, same spot just for sunlight, same amount of water, and those are 3 examples. Okay, good. And let's go to number 2. According to the data in the table, which fertilizer should Samantha use to help her grow large sunflowers quickly? So if I'm looking at my chart, which one of these which fertilizer should she use to help her sunflowers grow quickly? Support your answer with evidence from the text. So if I wanted to grow quickly, we said that pot number 2, brand B fertilizer, look, it grew the most. It like doubled in size. So we're going to put pot number 2, brand B fertilizer. So I'm going to start a new text box. Oops. So Samantha should use brand B fertilizer because the plant doubled in size each week and grew 18 centimeters. I think that's what it grew. Let's go back and check. Okay, yes. Support your answer with evidence. So we're going to back it up with evidence from the text. So the chart shows me that at week 4, Samantha's plant, or plant number 2, grew 18 centimeter, which was the highest. Very good. Okay, next one. Number 3, Samantha decides to use brand C fertilizer to grow her flowers. She believes that if she adds 2 teaspoons of brand C fertilizer instead of 1, she will grow sunflowers the fastest and tallest. Do you think this is a good idea? Explain. So, Samantha decides to use brand C fertilizer to grow her flowers. And remember, brand C was not the best fertilizer because her plant did not grow very much. Do you think this is a good idea? Explain. So if we doubled it, on week 1, she had 3 teaspoons of fertilizer. So it didn't grow any. So if we had 6, which would mean week 2 had 6, it did not grow very much. All right, sorry guys, we had to pause for a minute. So we're working on number 3. Samantha decides to use brand C fertilizer to grow her flowers. She believes that if she adds 2 teaspoons instead of 1, of the brand C fertilizer instead of 1 teaspoon, she will grow sunflowers the fastest and tallest. Do you think this is a good idea? And we're going to explain. So if we look at our chart for pot number 3, brand C fertilizer. Now on this one, she's only using 1 teaspoon. So if we add 2 teaspoons, our numbers will double. So 0, if we double that, it's still 0. 0, if we double that, still 0. 1 centimeter. Crazy. Sorry, she's being bad. If we double 1 centimeter, it will be 2 centimeters for 3 weeks of brand C fertilizer. And then our last week, number 4, or week 4, the plant only grew 2 centimeters. So if we double that, that's only 4 centimeters. So do you think that's a good idea? Probably not. And our plant grew the least with brand C fertilizer. So we don't think it's a good idea. So Samantha should not use brand C fertilizer. And we're going to type this in. Samantha should not use brand C fertilizer because would only double in size from 2 centimeters to only 4 centimeters. And we're going to prove it. So the chart shows me that this plant grew the least compared to the others, compared to the other plants. The plant only grew 2 centimeters in 4 weeks, which would only mean it would grow 4 centimeters in all if we doubled the amount of fertilizer. Okay, so you can tell that I proved my answer with evidence from the chart. You're going to do that as well. Now we did this on Cami. Now what you're going to do in a minute is you're going to answer the same type of questions about another experiment. This one right here about Jack's tomato plant production. So you're going to read this and then think about what are the independent variables. Let's see. What's the independent variable? The one thing that he's going to change. What's the dependent variable? What is happening because of this experiment? What's he trying to gain from it? The control variables are what he keeps the same. So you need to remember that. And you're going to answer the following questions about Jack's experiment on your own. Number 1, you're going to summarize Jack's experiment. So in shorter terms, tell us what happened in Jack's experiment. What did he find out? What did he do? Number 2, what variable did Jack measure in his experiment? So if he's measuring it, that would be his dependent variable, okay? Number 3, according to the graph, how many hours of daily sunlight should his tomato plants receive in order to produce the greatest amount of tomatoes? So how many hours of sunlight should they receive to produce the greatest amount of tomatoes? And here's a challenge question for you, number 4. Here's a bonus question. Jack did his best to control all the variables except for sunlight in his experiment. What variable or variables might not have been controlled and thus could have affected tomato plant production unknowingly to Jack? So think outside of the experiment. What other variables could affect how his tomato plants grew? Okay, think about outside, think about the weather, think about this year and our tomato plants. Maybe you grew a garden. What affects that? Think of the outside factors. So that's a bonus question for you. Now, what I want you to do, and we're going to know if you watch this whole video or not, when you open up your Kami for narrative number 1, we did it together. So we will know if you watch this video, if you put really big in text box right here, in a text box, put completed in class together, because we've already did it. So you don't have to type it all out. But if you didn't watch the video, then we'll know you didn't watch the whole thing. But you are going to answer the number 2 questions down here. 1, 2, 3, and number 4. Okay? And you're going to type it using Kami. And then when you're finished, up at the top, remember to click Turn In for us, please. Okay? If you have any questions, make sure to let your teacher know. And we will see you at the next video. Bye, guys. Have a good day.